Hi, welcome back to Unit 9B, our first day of this section. We are talking about tangents, and we already talked about the tangent is a segment or line that only touches a circle in one place. The place it touches is my point of tangency, and that segment with the radius will always be perpendicular and create a 90-degree angle. Okay? Our next property that we're going to talk about with tangents, say if two segments from the same exterior point are tangent to a circle, then they are congruent. So for example, if line RS, so if I were to extend this line, and line ST, so extend this one, if they're both tangent, then the segment to where they intersect, so this is a point that is on both of these lines, and it's exterior. So this is a common exterior point because it's in both of these segments, right? Point S is part of both of those segments. So that means that those two tangent segments are going to be congruent. So segment RS is going to be congruent to segment ST. This piece here will have the same length as this piece here. Okay, so when I look at my examples and it says to find x, well, the first one's super simple, right? If these are tangent segments, and we probably need to add that into our directions. Segments that appear, and you'll see this in your assignment, segments that appear tangent are tangent. Because remember, we're real big in geometry about never assuming anything. So segments that appear, oops, I forgot to write the word appear, tangent are tangent. Okay? All right, so when I look at this one, these two segments appear to be tangent with these points of tangency. Here's my common exterior point, so that means that the 12 and the x have the same length. So x equals 12. Okay. On the next one, same thing. I can see that these appear tangent, where B is a point of tangency, D is a point of tangency, and then they have a common point outside the circle, a common exterior point. So that means these two pieces are going to be congruent. So x plus 3 should equal 7. To solve this, all I have to do is take away 3. And x equals 4. Okay, sometimes you have a polygon that is what we call circumscribed about a figure. And that just means that the polygon, every single side of the polygon is tangent to the circle. Okay, all the sides of the polygon are tangent to the circle. So if you look at this hexagon A, B, C, D, E, F, it is circumscribed about circle P. So every single one of these segments are tangent to the circle. So each one touches the circle in just one spot. Every side has a point of tangency as you go around this hexagon. So 6 points of tangency because 6 sides. My square, GHJK, is circumscribed about circle Q, so that means it has 4 sides, so there are 4 points of tangency. Okay, so let's look at this example. Triangle ABC is circumscribed about circle O. Find AD and the perimeter of ABC. Okay, so the first thing it wants me to find is AD. So D is my point of tangency, and I'm looking for this exterior tangent segment. And I can see that point F is a point of tangency, and so it's going to match with this. And then look, point A is a common external point. So that means these two pieces must be equal. So AD equals 12. Okay, but wait, there's more. This triangle also, we want to find the perimeter. So I can do that with each one. If D is a tangent and E is a tangent and B is my external common point, then both of these have to be 6. And then, if F is a point of tangency and E is a point of tangency, and C is a common external point, then both of these have to be the same. So if this is 8, this is also going to be 8. So then when it asks me to find the perimeter, I can do that, right? Because I can say, all right, this side is this 12 plus this 6. So this whole side of the triangle is 12 plus 6, 18. This side of the triangle is 6 plus 8, which is 14. And this side of the triangle is 12 plus 8, which is 20. So for my perimeter, I just need to add up all my sides, right? The 20 plus the 18 plus the 14 is going to give me my perimeter. So that's 12, carry the 1, 2, 3, 4, 5, 52. I don't have any units, so we'll just say 52 units for my perimeter. And then AD, I didn't put units on it, we'll go ahead and do that, is 12 units. Okay? All right, come on back for the next video. In the next video, we will do some mixed practice using all the properties that we talked about when working with tangent segments. Thanks so much for watching.